Welcome back to Intro to Programming with C++. Today we're going to be looking at all these different sorts of data types we have out there for our numbers and how we can store them. What's the difference? What is similar? What should we use? So let's get started. First, I'm going to look at integer data types. Integers, as you recall from your math courses, are positive or negative whole numbers. So no decimal or fractional parts. We have three main integer data types: short, int, and long. They all hold whole numbers, positive or negative. So what's the difference? Well, the difference is how much space they take up in memory. Short uses the smallest amount of memory, int uses a medium amount, and long uses the most. What happens when you use one of these data types, see over here, short num, there is a location made in memory of enough to hold a data type short, and it's given the name num. Num is there for us so that we can access the variable. Here on the next line, num is stored the value of -7. So why do we have the different data types? Well, the amount of memory is the main reason. If you are using a lot of these data types, you might not want to allocate too much memory to each one. You can save memory for other purposes on your computers. But there is a drawback. If you're using less memory, the number being stored can't be as big. So the short uses less memory, but it's the least variable of the variables. So short can use values up to about 30,000 or so typically. I'm not going to get the exact numbers down because it can actually vary by computer or by compiler. Int, medium length, if you're using numbers less than about a billion or so, you should be okay using an int. And long can go bigger than that. There is a way to check the size of these variables. It's called the size of function. You can look it up. I'm not doing that in this video. So what do I usually use? I usually use int. It hits the medium value, and it's plenty big enough to store most of the numbers I need it to store. But those are all out there. There's a variant on each of these, the unsigned data types. These will only hold positive numbers, so only use them in cases where you will not be having a negative number. It'd be unsigned short, unsigned int, unsigned long. You do this in the same way that we did the other. You put the data type, even though it's two words, it's okay. You just put the data type first, and then you put your variable name that you want. That could be anything. And you can store values in there and do other stuff with them after that. The only real benefit to this that I see is that it shifts all the memory allocation that's available from being just there for the positives and negatives to only positives. So now you actually have twice the range in the positive numbers that you would have if you had just the positives and negatives. That said, I usually just stick with the basic int variable or data type for myself. There's a special integer data type. There's a lot of integer data types. Here's a special one, and we'll have another special one at the end of the video. This is the character data type. The character data type, C-H-A-R. I usually just say char. Character data type is still an integer, but it's a number that represents a single character or letter. It doesn't have to be letter because there are other characters out there. But here is the character of capital A. Notice it's enclosed in single quotes. That's telling the compiler that we're talking about the character A, not some variable named A. I want to cut out of this and look at the program that was excerpted from to show you something with these character data types. So I'm going to run this. The letter A is stored in the variable named letter. So when it prints it out, it should print out the letter is A, period, enter, enter. Compile. And run it. The letter is A. Nice. Now, here's the weird thing. This is really a number. Every letter has its own number assigned by the ASCII code. I'm not going to print out the code here. You can search for it. It's on Wikipedia. Of course, it's in the back of your book. That would be another place to spot it, but it tells you which number represents which letter. Notice what just happened here as I was talking. I said the letter is 65. It printed out a letter A. 65 is the number that corresponds to the character capital A. If I switch just, there we go, I think I'm going. As I switch to 66, compile, run it, good. The letter is B. So it actually will print out, and you can, this is one way to find out which character is assigned which letter. You can, I have no idea what goes with 111, but you can see which character and which number go together. Lowercase o, all right. But what's happening is, because this is an integer number stored in character, it gets converted for our purposes to a single character. All characters are stored as numbers, and this is a good way to see that. Go back over here. So that's the character data type. Now we get to the floating point data types. These are not integer data types. Floating points are really decimals. The point is the decimal point. Float, double, and long double. Just like the integer data types, the difference is how much memory they're allocated. So that is also the difference of how big a number you can do. In the case of the floating point data type, it affects both how large or how small a number you can do, and how many significant digits are kept in memory. I do want to point out here that you put these in, you can store numbers as a decimal. There's another way to do this with the E notation. This is much like many of your calculators do for very large or very small numbers. This is scientific notation. 3.4 E72 really means 3.4 times 10 to the 72. This is the way a human would write scientific notation. Or you could write it out the long way. It keeps track of those long or small decimal places. But for decimal values, think programs that keep track of money, for example, you probably want to use a floating point data type. The most common one, double. One more integer data type, actually, is a Boolean data type. We're not going to use this much right now, but I want you to know what's out there. B-O-O-L. Boolean logic refers to values that can either be true or false. So this Boolean data type gets stored a value of true or false. Actually, it's a 0 or a 1. True is the same as 1. False is the same as 0. And it will hold only one or the other values. So that is an overview of all these data types. Hopefully it helps make those clearer, or at least break them down into categories.